Picture two pieces of wood left out in the rain. One is wrapped in a glossy modern coating that looks perfect for a year, then starts to crack, blister, and peel. The other looks almost unfinished. No thick film, no plastic shine, just wood, and yet water keeps beating on it season after season because the protection isn't sitting on top. It's inside the grain. That sounds like one of those too good to be true internet claims. A cheap oil, ancient origins, better than paint, supposedly banned, supposedly hidden, supposedly forever. The truth is more interesting than the myth. The oil in question is tung oil, sometimes called China wood oil, and unlike the dramatic version in the title, it was not banned in 1934. What really happened is less cinematic and more believable. Tung oil was a respected wood finish with a long history, and it became strategically important in the early 20th century, and then it slowly lost ground to faster, more industrial coatings that fit mass production better. Not because it was magic, not because it was outlawed, because chemistry, economics, weather, and consumer habits changed. Still, the core idea is real. Tung oil is one of the most effective natural drying oils ever used on wood. It penetrates, cures by oxidation, and leaves behind a flexible, water-resistant network inside the surface fibers. That made it valuable for furniture, tools, boats, architectural woodwork, and finishes that needed to survive moisture without turning the wood into a shell of peeling plastic. So if it was this useful, why did it fade from everyday knowledge? And what can it actually do that modern coatings often fail to do? But that is where the story becomes worth telling, because this is not a tale about miracle oil. It is a tale about how older materials were often designed around patience, maintenance, and long service life, while many modern products were designed around speed, consistency, and easy retail sales. One approach ages with the wood, the other often fights against it, and wood always wins that fight eventually. Long before hardware stores sold deck sealers by the gallon, people had the same problem we have now. Wood swells when wet, shrinks when dry, and if moisture lingers in the wrong place, fungi begin turning structure into food. Ancient builders did not talk about moisture cycling or polymer cross-linking, but they understood failure. Ships leaked, handles split, walls rotted. So different cultures experimented with oils, waxes, tars, and resins to slow water down. In China, tung oil was known for centuries, with references reaching back deep into the classical world. It came from the seeds of the tung tree and became especially important anywhere wood had to face weather. Chinese craftsmen used it in waterproofing, finishing, and coatings. Medieval accounts from travelers to Asia described shipbuilders using mixtures that included oil, lime, and fiber to seal boats. Whether every retelling was precise is hard to prove, but the broad historical pattern is clear. Tung oil was not a modern gimmick. It was part of a real finishing tradition. By the early 20th century, the United States became fascinated by it. The tung tree was introduced into the Gulf Coast region, where growers hoped it could become a profitable crop. That hope was not irrational, but the oil had real industrial demand in paints, varnishes, inks, and protective coatings. In the decades before and during World War II, American tung orchards expanded across parts of Florida, Mississippi, Alabama, Louisiana, and Texas. The industry grew large enough that tung oil was treated as strategically important during the war years. It mattered because good coatings mattered. Then came the collapse, and this is where internet storytelling usually replaces history with conspiracy. The American tung industry was not wiped out by a secret ban in 1934. In fact, the 1930s were years of expansion, lobbying, research, and cultivation. The real damage came from a combination of forces. Synthetic resins improved, industrial coatings got faster and easier to standardize, imports changed the market, and Gulf Coast weather, but especially freezes and destructive storms, hit orchards hard. By the late 20th century, the domestic industry had largely withered. That rise and fall says something important. Tung oil did not disappear because it failed, but it also did not disappear because it was too perfect for the world to handle. It lost because natural materials often struggle in an economy that rewards fast drying, shelf stability, uniform results, and low labor application. When consumers want a finish they can brush on today and walk on tomorrow, patience becomes a commercial disadvantage. So what makes tung oil different from ordinary oil? The answer is that it is not just oily, it is a drying oil. That means it reacts with oxygen in the air and transforms from a liquid into a solid network. Instead of simply soaking in and staying greasy, it polymerizes. Molecules link together. The finish cures within and near the surface of the wood. That matters because wood is not a flat slab. It is a bundle of tiny channels and cell walls that move moisture constantly. Some coatings form a film mostly on top. They can look beautiful at first, but when sunlight, foot traffic, and seasonal expansion start working on them, the film can crack. Once water slips under that cracked film, it often gets trapped. Now the coating that was supposed to protect the wood begins helping to damage it. Tung oil works differently. Applied in thin coats, it wets the fibers, penetrates the upper structure, and cures into a more flexible, water-resistant barrier that moves with the wood better than many brittle surface films. Not perfectly, not forever, but often more gracefully. Now that's why old oil-based systems tend to wear by thinning, dulling, or chalking instead of peeling off in sheets. There is another reason tung oil became so respected. Compared with linseed oil, which also has a long history, tung oil generally cures into a harder and more water-resistant film. Linseed oil can deepen color beautifully and has valuable uses in paints and wood treatment, but pure tung oil is often favored when moisture resistance matters most. That does not make it indestructible. Ultraviolet light still ages it, standing water still tests it, abrasion still wears it down. But chemically, it is a strong natural candidate for wood protection because it creates a dense cured structure rather than remaining a soft, wet dressing. This is also the place to correct the biggest myth. That wood treated with tung oil is not waterproof forever in the absolute sense. No finish gives outdoor wood immortality. Sunlight degrades binders. Temperature swings stress surfaces. Water finds joints, end grain, fastener holes, checks, and neglected edges. Even the best natural oil is still part of a maintenance story. What tung oil really offers is deep water resistance, elegant aging, and repairability, and for many real-world uses, that is more valuable than the fantasy of permanence. Modern coatings are not villains. Many are genuinely excellent. High-performance exterior paints, marine varnishes, penetrating stains, and specialized sealers can outperform old methods in specific situations. If you want color retention, quick curing, chemical resistance, or a predictable film build, synthetic chemistry has obvious advantages. That is why industry moved in that direction. But the trade-off is easy to miss. A lot of modern coatings protect by building a layer on top of the wood. When that layer is intact, it can work very well. When it fails, maintenance becomes expensive because failure is often dramatic. Scraping, sanding, stripping, recoating, repeating. Older oil systems often feel less spectacular at first because they do not create that thick showroom surface. Yet when they weather, the fix can be simpler. So clean the wood, apply another thin coat, restore what faded instead of removing what peeled. There's also a cultural difference. 20th century coatings were sold into a world that valued speed. Faster drying meant less waiting on job sites. Factory-made finishes meant more uniform products on retail shelves. Synthetic resins meant manufacturers could tune gloss, hardness, color retention, and curing time. In other words, they were easier to industrialize. That does not mean they were always better for every board, fence, or cabin wall. It means they were better for the modern marketplace. Cost is another place where myths get inflated. Tung oil is not always a $2 miracle, especially if you buy real pure tung oil and apply enough thin coats to do the job properly. It can still be economical, but the savings are not magical. But the real advantage is not that it costs almost nothing. The advantage is that it can deliver respectable long-term performance without creating a brittle plastic shell, and when the finish finally needs attention, the maintenance process is often gentler. And there is one more point most viral claims leave out. Product labels are slippery. Many cans sold as tung oil finish contain very little tung oil or mix it with varnish, solvents, and other additives. Some of those blends are useful, some are misleading. The history of natural oils was not just buried by chemistry, it was also blurred by marketing. Used wisely, tung oil still has a place. It makes sense on tool handles, outdoor furniture under moderate exposure, doors, trim, small boats, cutting boards when the product is food safe and fully cured. And then woodworking projects where you want the grain to stay tactile instead of looking encased. It can also be part of a broader traditional approach, with compatible primers, paints, or maintenance oils, depending on the application. The key word is wisely. Outdoor decks in punishing full sun may still demand regular upkeep. Softwoods with exposed end grain need extra attention. Raw wood has to be dry and clean. Thick coats are a mistake because curing happens through oxygen exposure, and a heavy layer can stay gummy. Thin coats matter. Wiping off excess matters. Cure time matters. And oily rags absolutely matter because they can heat up and ignite if crumpled and left carelessly. This is why older finishes reward patience more than shortcuts. You are not painting over the wood, but you are feeding a controlled amount of reactive oil into the surface, then allowing chemistry to finish the job. People who expect instant gloss and instant hardness often decide the old material is inferior. People who let it cure and maintain it properly often discover why it lasted in workshops for generations. If you want the most honest takeaway, it is this. Tung oil is not the universal answer for any wood, any climate, forever. But it remains one of the smartest traditional answers when you want a natural-looking, repairable, water-resistant finish that ages with dignity instead of failing all at once. So the mystery in the title resolves into something both less dramatic and more useful. No, a miracle oil did not kill the paint industry. No, it was not banned in 1934. And no, no finish makes wood immortal. But yes, though there really was an old material with a remarkable reputation, a deep history, and a chemistry strong enough to survive centuries of practical use. What tung oil represents is not forbidden knowledge. It is neglected knowledge. The kind that disappears when faster products, louder marketing, and shorter attention spans reshape what people expect from materials. The forgotten lesson is not that the old world had magic. It is that many traditional builders understood something we keep relearning. Wood lasts longer when the finish works with its nature, instead of trying to imprison it under a flawless skin. And maybe that is why this story still resonates. Not because tung oil can do everything, because it reminds us that better is not always newer, and convenience is not always durability. And if you enjoy learning about practical knowledge that most people overlook, consider subscribing.